There's a world 1.4 billion kilometers from Earth where it rains gasoline, where lakes stretch for hundreds of kilometers, but they're not filled with water. They're filled with liquid methane, cold enough to freeze your body solid in seconds, where the air is so thick you could strap on wings and fly like a bird. This is Titan, Saturn's largest moon, and nothing about it makes sense. For most of human history, we thought Saturn had 6 moons, small, icy, unremarkable. Then in 1655, Dutch astronomer Christian Huygens pointed his primitive telescope at Saturn and saw something enormous orbiting the planet, something bigger than the planet Mercury. He named it Titan. For 350 years, Titan remained a mystery, a blurry orange dot in our telescopes. We knew it was big, we knew it had an atmosphere, but we had no idea what was hiding beneath those clouds. Then in 2005, everything changed. The Cassini spacecraft released a probe called Huygens, and for the first time in history, humanity landed on a moon in the outer solar system. What it found shouldn't exist. Titan is the only moon in our solar system with a thick atmosphere, not a thin wisp of gas like our moon, a real atmosphere, thicker than Earth's. If you stood on Titan's surface, the atmospheric pressure would be 1.5 times what you feel right now. You could walk around without a pressure suit. But here's where it gets strange. The atmosphere is 95% nitrogen, just like Earth. The remaining 5%. Methane, the same gas we use to heat our homes, and at Titan's surface temperature of negative 179 degrees Celsius, methane doesn't just float around as a gas. It condenses, it forms clouds, and then it rains. Imagine standing on Titan as a methane storm rolls in. The clouds are thick, orange, choking out the weak sunlight filtering through from Saturn. Then the rain begins. Not water, liquid methane, falling in huge, lazy drops through the thick atmosphere. Each raindrop 6 times larger than rain on Earth, drifting down like snowflakes because the gravity is so weak. The rain hits the ground and doesn't evaporate. It pools, it flows, it carves rivers into the landscape, and eventually it collects in vast lakes and seas. Titan is the only place in our solar system besides Earth with stable liquid on its surface. But these aren't tropical lagoons. They're seas of liquid, natural gas, cold enough to shatter steel like glass. The largest of these lakes, Kraken Mare, is bigger than the Caspian Sea. It contains more liquid hydrocarbons than all of Earth's oil reserves combined. If you could somehow transport it back to Earth, it would power our civilization for thousands of years. Cassini's radar mapped over 650 lakes and seas on Titan's surface. Most cluster near the North Pole, where the temperature drops just low enough for methane to remain stable. Some of these lakes are over 200 meters deep. But here's what's truly bizarre. These lakes don't just sit there, they evaporate. Methane rises into the atmosphere, forms clouds and falls as rain again. Titan has a complete liquid cycle, just like Earth's water cycle, but made entirely of rocket fuel. And the shorelines, they're not sand, they're made of water ice. On Titan, water ice is as hard as rock. The pebbles on the beach are frozen water. The bedrock beneath your feet is a shell of ice, hundreds of kilometers thick. Everything about Titan defies what we think we know about moons. Let's start with gravity. Titan's gravity is just 14% of Earth's. That's 1/7. If you weigh 70 kilograms on Earth, you'd weigh 10 kilograms on Titan. You could jump 7 times higher, run faster than an Olympic sprinter without even trying. But here's where it gets insane. Because the atmosphere is so thick and the gravity so weak, a human could fly on Titan. Not with a jetpack, not with a plane, with wings. Strap on a pair of lightweight wings, flap your arms, and you'd lift off the ground. Titan is the only world in our solar system where human-powered flight is possible. Now let's talk about time. A day on Titan lasts 16 Earth days. That's how long it takes to rotate once. But because Titan is tidally locked to Saturn, one side always faces the giant planet. Saturn dominates the sky, 70 times larger than our moon appears from Earth. Imagine looking up and seeing that. And the seasons? Each season on Titan lasts 7.5 Earth years. Summer, winter, spring, fall. Each one a lifetime for us. Cassini watched Titan for 13 years and witnessed less than 2 full seasons. As Cassini continued mapping Titan, it discovered something nobody expected near the equator, stretching for thousands of kilometers. Sand dunes, massive, parallel dunes, some over 100 meters tall. They look exactly like the dunes in Earth's deserts, but they're not made of sand, they're made of ice. Tiny grains of frozen water and hydrocarbons sculpted by winds that blow at just 1 meter per second. That's less than 4 kilometers per hour, slower than you walk. But in Titan's thick atmosphere, even gentle winds can move material across vast distances. The landscape is alien in ways that break your brain. Mountains made of solid water ice, rivers that carved canyons millions of years ago, but those rivers flow with methane, not water. Impact craters, but they're shallow, eroded by rain that falls from the sky every few decades. And beneath all of this, beneath the lakes, beneath the dunes, beneath the icy crust, something even stranger, something that might change everything we know about where life can exist. In 2012, scientists made a discovery that changed how we see Titan. By tracking radio signals from Cassini as it flew past Titan repeatedly, they detected something, a wobble. Titan's icy shell was flexing as it orbited Saturn, and there's only one thing that could cause that. Liquid, buried beneath 100 kilometers of ice. There's an ocean, not methane, water. A subsurface ocean of liquid water mixed with ammonia, preventing it from freezing solid despite the cold. This ocean might be 200 to 300 kilometers deep, deeper than any ocean on Earth. And here's what keeps scientists up at night. That ocean is in contact with Titan's rocky core, water, rock, organic chemistry, the same ingredients that might have sparked life on Earth 4 billion years ago. But there's a problem. This ocean is buried, sealed off from the surface by an impenetrable ice shell, cut off from sunlight, cut off from the methane lakes above. If anything lives down there, it would be life in permanent darkness, feeding on chemical energy seeping up from the rocky core. Life that has no idea the universe above even exists. 2 oceans, one of liquid methane on the surface, one of liquid water deep below, separated by a shell of ice. And we don't know if either one contains life. Titan isn't just a world of lakes and oceans, it's a giant chemistry lab. Every day, ultraviolet light from the sun strikes Titan's upper atmosphere, splitting apart methane molecules. The fragments recombine into more complex molecules: ethane, propane, acetylene, benzene, molecules that on Earth only exist in oil refineries. These complex hydrocarbons rain down onto the surface. They mix, they react, and slowly over millions of years they build up. Scientists call this organic haze tholins. It's what gives Titan its orange color, and it's made of the same building blocks that formed amino acids on early Earth. Titan is doing organic chemistry at a planetary scale, without life, without intervention, just physics and chemistry, creating complexity out of simplicity. In 2010, scientists discovered something strange in the data from Cassini. Hydrogen was disappearing from Titan's atmosphere faster than it should. Something was consuming it, and at the surface, acetylene was also disappearing. 2 separate chemical anomalies. One possible explanation? Methane-based life. organisms that breathe hydrogen instead of oxygen, that use liquid methane instead of water. It sounds like science fiction, but the chemistry works. On paper, it's possible. We don't have proof, but we have questions, and in science, questions are often more valuable than answers. In 2034, we're going back to Titan. But this time, we're not just dropping a probe, we're sending a drone. NASA's Dragonfly mission will launch a nuclear-powered rotorcraft the size of a car. It will fly through Titan's skies for years, landing at dozens of locations, analyzing the chemistry, searching for signs of life. Because Titan's atmosphere is so thick and the gravity so weak, flying there is actually easier than flying on Earth. Dragonfly will be able to cover hundreds of kilometers, exploring regions that would be impossible to reach with a stationary lander. It will sample the organic material on the surface. It will study the methane lakes. It will analyze the ice. And if it's lucky, it might find something that changes everything. Titan is a time machine. It's what Earth might have looked like 4 billion years ago before life began. Organic chemistry happening everywhere, liquid cycles, energy sources, all the ingredients, just waiting. If we find life on Titan, it won't look like anything we've ever seen. It would be life based on completely different chemistry. Proof that the universe has more than one way to create living things. And if we don't find life, that might be even more interesting, because it would tell us that having the ingredients isn't enough, that something else is required, something rare. For most of human history, we thought Earth was special, the only world with oceans, the only world with weather, the only place life could exist. Titan proved us wrong. It has lakes, rain, rivers, coastlines, seasons, clouds, a nitrogen atmosphere, 2 oceans, organic chemistry everywhere. It's shockingly Earth-like and yet completely alien at the same time. Titan tells us that the universe is far stranger and far more diverse than we ever imagined, that worlds can be habitable in ways we never predicted, that liquid doesn't have to be water, that life doesn't have to breathe oxygen. And Titan isn't rare. There are dozens of icy moons in the outer solar system: Europa, Enceladus, Ganymede. All of them might have subsurface oceans. All of them might have the ingredients for life. We used to think life was confined to a narrow, habitable zone around stars. A Goldilocks region where it's not too hot, not too cold. But Titan is way outside that zone, and it doesn't care. It has found its own way to be habitable. The question isn't whether there's life in our solar system. The question is, how many different kinds of life are out there waiting to be discovered? Right now, Titan is halfway through its 29-year orbit around the Sun. Its northern hemisphere is warming, the methane lakes are evaporating, storms are forming, rain is falling in places that have been dry for years. Cassini watched for 13 years. It saw the seasons change, but it only scratched the surface. When Dragonfly arrives in 2034, it will land during Titan's summer. The lakes will be calm, the weather stable, perfect conditions to search for answers. Because somewhere on Titan, in the methane lakes, in the subsurface ocean, in the organic haze raining down from the sky, might be the answer to the oldest question humans have ever asked. Are we alone? Subscribe for more journeys to impossible worlds.